Institute of Technology, Bangalore, India. He is also serving as head R&D at MSRIT, as well as heading the Center for Imaging Technology at Rama Institute of Technology. Dr. Sriram is author and co-author of 180 articles published in peer-reviewed journals and conferences. Currently, he is involved in 1.5 crores worth sponsored research funded projects. His current research interests include biomedical signal processing, cognitive neuroscience, data mining, neural networks. He is also serving as editor-in-chief of the International Journal of Biomedical and Clinical Engineering Journal. Dr. Sriram is senior member of IEEE and IEEE Engineering and Medicine Biologist Society, EMBS, Signal Processing Society, life member of Telemedicine Society of India, and member of Medical Computer Society of India. He is serving as chairman of IEEE EMBS Chapter Bangalore, Section India. He is also serving as technical committee member, MSIPS, the Medical Health Group, Minister of Information Technology Communication, Government of India. Technical member of Indo-Israel Cooperation Project. So this is the very brief introduction about today's speaker for session 1. Once again, on behalf of my institute, on behalf of the organizing committee of Electronics and Instrumentation Department, I welcome the today's speaker, Dr. N. Sriram, for this FDP. Now, I hand over the session to Dr. Sriram. I request all the participants to mute your microphone and video, and also I request all the participants to stop chatting. Okay, so you can able to post your question almost at the end of the session, which is about to complete. And once the interaction session starts, at that time you can unmute and ask the question to the speaker. Okay, with this request, now I hand over the dais to Dr. N. Sriram. Thank you, Anand. Professor Sriram, you can go for sharing your screen now.
I'm trying to upload the slide.
Present now. There is a bottom icon. Present now.
Yeah, that's what I'm doing.
Okay.
And then start your entire screen.
Go to entire screen.
Yeah, that's what I'm doing.
Yeah. Yeah.
Is the slide is visible?
Yes, sir. Your slides are visible now for us.
I will mute my video also to.
Okay.
So very good morning, one and all. First of all, I would like to thank Dr. Soli and his team for giving the opportunity to share my experience in this domain. Talk is on both two different areas. The first one is about the fundamentals or the perspective, since the focus area is biomedical engineering. So I'll be giving the glimpses on the perspectives. Some of the content are taken from the open sources, which I have been attracted with those information. And here I'm going to give the glimpses on the machine learning or AI in healthcare, and what are the opportunities, challenges for the engineering fraternity or the faculty members to take a lead on this domain. Then I'm going to talk about what are the open source data available which you can access the the data for your research. Then my second talk will be on the computer aided diagnosis on a one-dimensional and two-dimensional signals using the neural network modeling. Friends, when you look into the current scenario, this is one of the website where you will find the day-to-day or every second information about the amount of healthcare requirement or the clinical requirement. For example, those who met with any kind of accident, chronic disease, non-chronic disease, whatever it may be, this world clock will give the updates. It's totally a kind of a, an unimaginable scenario in the sense that the engineers and the clinicians need to join together to provide a kind of a solution which is an essential component for today's scenario. The right field is the engineering field is the biomedical engineering field, which is a multidisciplinary field where the integrated component of engineering and medicine are two different domains. By taking the biological aspects, we can brand this field as a kind of interdisciplinary domain as well as the cross-disciplinary domain. Taking this biomedical engineering into account, I want to give a short example. For example, see, in terms of today's technology, it has been highly influenced by the developments happening in this biomedical engineering field. This is a specialized field that integrates engineering and medical domains into a single platform. One fine example I can refer is a kind of a wearable physiological monitoring system. It's a need of the hour where the patient data or any healthy volunteers or any volunteers data can be remotely accessed, which are being used for home healthcare delivery, can be considered as one best example for the technological development in field of this biomedical engineering. This wearable system generally composed of a specialized sensor embedded into a wearable shirt or maybe a t-shirt for data acquisition along with a processing unit. The data are sent to the monitoring station using a wireless transmission. So the role of artificial intelligence is predominant here. It is about the technology advancements which remotely access the patient data or a volunteer's data remotely, and any kind of interpretation is feasible. This is one specific example. Looking into the arena of this medical and engineering domain, starting from 1950s, 70s, 60s, 80s, and the present day technology, this information give a clear-cut picture about the path which we have come across about the technology development. When I say technology, it's about the device development with the help of engineers and the clinicians together. So when you look into this thing, the present technology is about the image-guided surgery. It's nothing but a robotic surgery, which was quite prominent in Western countries. Now in countries like underdeveloping countries and developing countries like India have taken this path using the technology where the role of engineers or specific the clinical engineer or biomedical engineer is predominant in such kind of applications. Looking into the convergent technology here, the new generation of medical technology products are combination of different technology which lead to the crossing of both traditional categories of medical products such as medical device, pharmaceutical products, or human tissue. So the convergent technology, when you look into the present scenario, the AI plays a very, very important role that we need to understand. In terms of the challenges in the biomedical engineering, this is a kind of a very fascinating field because if you name any engineering field, it will be a part of the biomedical engineering. And it has to communicate across the disciplinary boundaries to convert or translate the information into a fruitful solution. So the first and foremost things in this field is we need to understand the problem. So you need to consider the anatomical and the physiological perspective because you are going to provide a solution to the healthcare. So this problem identification is very important part. Then you have to look into this dynamic behavior and the general
Excuse me, sir. The screen is not visible, sir.
screen is not visible.
In the starting, it was shown, but now there are a problem.
Okay, I will just look. Okay, because there may be a kind of an interruption because of the bandwidth. Now it is changing.
Hello, sir.
Yeah, it is changing. The
Excuse me, sir. Excuse me, sir. Slides are not visible, sir. Sir, can you again just try, sir? Present now. Go to present now. Now stop sharing. Present. Go to present now, sir.
Okay.
Yes, sir. Your slides are visible now.
Yes, sir. Now it's visible.
Okay, now it is visible.
Yes, sir. Visible, sir.
So these are the challenges in terms of the biomedical engineering, and the field is such a manner that it will have a multiple solutions. The amount of failure is predominant here. So these are the challenges of biomedical engineering. When you look into this biomedical engineering or the clinical engineering, fundamentally it refers to the nature of the biomedical signal or in terms of the physiological signal. So this is a very important part where we need to look into the extraction or the desired information by acquiring or processing of the biomedical signal. And we need to integrate the nature of the physical process.
Excuse me, sir.
Hello, sir. Excuse me, sir.
Yes.
I request the participant not to present their not to present now button. It will be disturbing our FDP program. So I think Manikanta sir.
Can I continue?
Sir, your slide is not visible, sir. Somebody has opened present now.
Okay, should I go again?
Sir, once again, sir. Sorry, sir, for inconvenience.
Fine. Can I?
So Manikanta Kumar sir, kindly stop your present now button.
Do we need to close it?
Entire screen. Yes, sir, now it's visible. Yes, sir, it's visible.
So, in terms of the physiological signals, one has to interpret the nature of the physical process based on the observation of the physiology signals or on the observation of how the process alters the typical characteristics or the behavior of the signal. So this is a very important part or a fundamental part when you look into the AA at a later stage. So the initial stage, this understanding is very, very important. When you look into the characteristics of the physiologic signals, most of the information will be hidden in the form of along with the noise or the artifacts. So the typical nature of the biomedical signals will be very, very complex and it's very dynamic, and we need to extract the hidden information. So that's why we apply different pattern recognition techniques, extract the important features and go for the machine learning or AI based algorithm for pattern classification. This is the typical generic overview of any kind of a biomedical signal analysis in the field of the biomedical engineering. It starts with the acquisition of the signals. It's a manual acquisition or a remote acquisition and an automated acquisition, wireless acquisition, wearable acquisition, whatever it may be. The important signal processing aspect is nothing but it starts with the acquisition, then the pre-processing, then before that we will have a components called transduction, isolation amplifier, then finally you will get a digitized data. Then to remove the artifacts and other things and all, we'll be using the pre-processing techniques and go for the specific event, feature extraction, classification. So when you look at the AA part, the last component is the AA part, which plays a very important role in terms of the clinical decision making. So these are the important objectives in terms of the biosignal analysis. Fine. What are the challenges in terms of this health informatics teaching? The first and foremost thing from clinical perspective is the diagnostic. That means which is visible. That means the signals are visible in nature. Can we extract something different from the clinical interpretation? And therapy, it's nothing but a control. Any kind of a stimulation, any kind of control mechanism can be introduced. Then therapy simulation, that means taking the real-time situation, we can simulate it and predict the future, how the performance of the data will be there in the near future. The next one is the knowledge-based decision support system, or we can also refer as early recognition and prevention. Then the neurorehabilitation aspects. So all these things are challenges in terms of the health informatics. Specifically in looking into the clinical engineering or the clinical informatics, in terms of the fundamental physiological signal, the first and foremost thing we need to give solutions to the intensive care unit, shortly called as an ICU. So the role of biomedical engineering is predominant in ICU. Then we always go for the analysis of the brain signal and heart signal, shortly referred as the electroencephalogram and electrocardiogram. And in terms of the ICU specifically, these are the factors which you need to look into it. And finally, to support the clinical community, we need to go for an automated intelligent alarm system, which is nothing but with the aid of the artificial intelligence, one can come with these kind of a mechanism which will help the clinical community. Fine. The fundamental in all these things is the biomedical data or the physiological data. So what is the purpose? The purpose of this is to improve the mechanism of clinical diagnosis or to help the clinical community. So what are the measurements? The measurement is based on the collecting the recordings of various physiological data and introduce the mechanism of signal processing, where the engineers will perform the quantitative assessment, where the clinicians will perform the qualitative assessment, and finally together put it together in the form of a effective clinical diagnosis. Now look into the perspective of the artificial intelligence. This is a kind of a mechanism, or we can say a model of intelligent behavior to understand the human behavior and to mimic the same. So the fundamental mechanism of artificial intelligence lies in the behavior of the brain. So this topology has been derived from the brain mechanism. It may be a natural language processing or a pattern recognition or data mining and decision support system. You name it, anything and all, artificial intelligence plays a very important role. So it is nothing but a mechanism of behavior, the human behavior that has been translated into in the form of a kind of a pseudo mechanism, or we can say pseudo codes or pseudo algorithms for implementation, or it's nothing but a simulated mechanism which can be translated to solve the real world problem. Machine learning is the most exciting area to provide a feasible solution to the healthcare sector. Why we have to go for the machine learning is, we know that the capability of the human brain, which can be very well translated into the artificial intelligence. So the human brain is comprises of the central nervous system is the fundamental region. So we will have axons, neurons, dendrites and synaptic effect. All these factors will be taken into account, and a computational mathematical modeling has been done that has been translated into a efficient algorithm which can process any kind of information and provide a feasible solution. Fine. What are the challenges or the machine learning in the healthcare or the clinical? The first and foremost thing is that the patient data, it may be their patient history, their record, starting with their name, date of birth, their family history, all those clinical record, it plays a very, very important information, because once you go to any hospital, the first and foremost thing the clinician will ask you whether you have any family history. If you go with heart related problem or sugar related problem, the first and foremost thing they will ask you about whether your family has any kind of this kind of history. So this is the first and foremost thing you have to understand. Then the nature of the clinical decision. The clinical decisions is very, very important, and we will see how the role of machine learning or artificial intelligence is predominant here. Now, what are the real benefits of the machine learning? Let me say that from clinical perspective, it's very safe to say that there are too many manual processes in medicine. For example, the clinician need to note the lab values, diagnosis, and other chart notes on the paper. The question arises that whether the technology can help improve the workflow as well as improve the patient care. That is the first and foremost. Since then, the advancement in the electronic and medical records have been remarkable, but the information they provide is not much better than the old paper chart they replaced. If the technology is to improve care in the future, then electronic information provided to the clinicians need to be enhanced by the power of analytics and machine learning. So when you look into the Western world, doctors have adopted these technology advances, but a country like India, we are going for the.
Excuse me, sir. Sir, just a minute, sir. Sorry to disturb you. I request the participant not to share their present now button. I think Shivkumar sir, stop present now button. Stop sharing the screen. Okay, once again request the participant not to press their present now button and share the screen. It will be disturbance for the session.
Ma'am, do I need to restart it?
Yes, sir.
Share the
Share the screen, sir. Sorry, sir.
No problem, no problem. Is the screen is visible?
Yeah, yes, sir. Yes, sir. Yes, sir. Now it's visible.
So using the machine learning analytics, we can provide a better information to the clinical community at the point of patient care. For example, having easy access to the blood pressure and other vital signs, one can consider the scenario of patient risk for stroke, coronary artery disease, kidney failure, where digitized data, for example, say continuous a 50 blood pressure readings, for example, taking a 1 week or 10 days time, lab test results, and other later clinical trials data using the machine learning will help in taking appropriate clinical decision. That is nothing but rather referring the all the information in a kind of a paper-based mechanism. Suppose I want to map the specific subject, what is the blood pressure and the sugar value yesterday, day before yesterday. So if I create a mapping, I can predict, okay, he is in the critical stage or a mild stage. Those kind of mechanism is possible only using the artificial intelligence technique. We need to advance more information to the clinician so that they can make better decision about the patient diagnosis and treatment options by understanding the possible outcomes and costs for each one. Hence, the value of machine learning in healthcare is its ability to process the huge data sets beyond the scope of human capability, then reliably convert analysis of the data into clinical insights, which can aid the physicians in planning and providing the care, ultimately leading to better outcomes, lower the cost of care, and increase patient satisfaction. So, when we say that this machine learning replaces clinician, yes, most of the clinical community, they consider this as a threatened thing to replace. No, in reality, it is not. Like in Western world, they do accept these kind of trend, and our country also is looking into the scenario of working together with the biomedical community or engineers or the clinical engineers. It's nothing but the technology is for helping the clinicians, not to replace the clinician. That's the very important message, because India is a thickly populated country where the amount of clinicians or the number of hospitals available in any rural or urban area doesn't cater to the needs of the population. So, suppose if I have a 70 patients standing outside a neurology department to screen for the brain signal analysis, if the doctor has to check it line by line and recording and see visually about this EEG, it will take more than 3 to 4 days. On the other hand, if you record the EEG and show a kind of an interpretation using your AI-based mechanism, it will save his time, and we can easily counter check it, because that's why we always go for any kind of a mechanism. We always consult the clinicians hand in hand, take their opinion. That will be incorporated in all kind of machine learning algorithms. And another mechanism in terms of the machine learning is the data drives. As more data is available, we can have a better information to provide the patient. That is called the predictive algorithms. So predictive algorithms and machine learning can give a better predictive model of mortality the doctor can use to educate the patient. So this is a kind of a very tremendous technology advancement in the sense that you can have the predicate logics to identify the level of mortality rate and introduce a mechanism to reduce the mortality rate. As larger data begin to run the machine learning, we can improve the care in more specific ways for each region specific or a demographic specific. When you look into the artificial intelligence medicine, it will have two branches. One is the virtual branch, as well as the other one is the physical branch. So the physical branch is nothing but the physical connectivity with the patient. The virtual is nothing but you remotely monitor all the vital recordings and take the important. So in terms of AI, the solution is to help the clinical community, and it should be more reliable and accurate. Keep in mind the clinical diagnosis is very, very important. Any wrong interpretation lead to erroneous results. That is nothing but when you assess a typical brain signal, the brain signal can have a normal pattern or an abnormal pattern. If your AI algorithm wrongly assess and highlight that your abnormal patterns as a normal pattern, then it will lead to kind of a very complicated result. So the requirement is the algorithm should be more robust and more precision so that it can be verified using different validation, clinical validation level, make it suitable for the clinical community. So the virtual components represented by the machine learning, now people are talking about the deep learning mechanism, but my focus will not be on this deep learning mechanism because I strongly believe that the main requirement for deep learning mechanism is we should have a more computational cost or more computational facilities like GPU, and in order to have a robust result or precision, you need at least 20,000 to 30,000 data samples. Otherwise, using a deep learning mechanism is meaningless, and that will not give a kind of a valid result. So this is very important in terms of the deep learning mechanism. So in reality, most of the resource constraint settings, I don't think it's feasible to have a kind of a supercomputer facility, availability of supercomputer with a high configuration of the internet facilities and all. It's ruled out. Deep learning mechanism may be one of the fruitful solution in the near future, but country like India, maybe we need to go for a robust algorithm at a low computational cost. In terms of the machine learning algorithm, there are three important mechanisms. One is the supervised one, the second one is the unsupervised one, the third one is the reinforcement learning. Okay. So the first one is nothing but, when you look into the supervised learning, is nothing but it's the interaction of the physician with the patient. So that means he will get all the patient history. He will try to annotate the data. For example, say, so for 2 hours of data, he will try to interpret it, and he will label those information. Then using the AI algorithm, the rest of the, say, suppose if you are having a 24 hours recording, the first 2 hours recording is annotated by the clinician. Rest of the data will be taken care by the AI algorithm. That is called the supervised learning. That means the target is known, the input is given, we have to train the algorithm based on the target. So if the simulated results is equal to target, that is the ultimate result. Otherwise, the error has to be minimal. The second case is an unsupervised learning. Unsupervised learning is nothing but you don't have a teacher, you don't know the nature of the targeted output. So we have to introduce a kind of a clustered mechanism to label the closely related patterns, and we have to classify it. And second one is third one is the reinforced learning, which is nothing but nature of the combination of the mechanism of supervised and the unsupervised learning. So based on the ability to learn, it will be predicted accordingly. Looking into the benefits of artificial intelligence for the clinical community, the first and foremost thing is it will give a very effective clinical decision making, in the sense that both qualitative and the quantitative assessment. Definitely it will not replace the clinician, but it will try to aid in taking a better decision. Then we will have all kind of open source facilities where we can come across about the importance of artificial intelligence, or the impact of artificial intelligence in the clinical care. Then next one, we can have the trend between the experienced clinician and the fresh clinicians. That's why people go for the simulated model. So a lot of mannequin are being used and using a kind of a simulated model, the fresh clinician will get a kind of insight about the technology. Then the next one is round the clock you will get the facilities. That means you will get the real-time analytical assessment of the clinical records round the clock. So these are the typical benefits of the artificial intelligence. Okay, in terms of the application, what are the different aspects? First one is the early diagnosis. That means prevention is better than cure. So early diagnosis is an essential component. For example, now it is the COVID era. COVID-19 screening is very, very essential. So we can easily use the data to highlight or diagnose whether any healthy people have a symptom of COVID. It's possible using the wearable technology and bringing the AI into account. Similarly, prediction. Then feedback on treatment. For example, say when a person has undergone a surgery, his physiotherapy mechanism, whether he has to move his arms or legs and all this physiotherapy mechanism, using the AI mechanism, we can bring a kind of an effective feedback. Then trying to reduce the diagnostic therapeutic errors that is often happens during the surgical process or anything, because sometimes some complicated surgery and all involves a AI-based mechanism. That's why people are going for robotic-based surgery or computer-aided surgery. Then the cost factors, the healthcare cost factor can be saved by implementing the AI technology. How it is? If the patient has to stay for 10 days in a hospital, using the AI-based mechanism, if you monitor the vital parameters round the clock, suppose 2 to 3 days of continuous recording will give a kind of a symptom that yes, the patient has recovered fast. Then instead of making the patient to stay for longer days, you can very well ask the patient can be discharged immediately. So that is one good example using the mechanism of AI. Well, in terms of the physical brand, so in terms of virtual brands, it's about the simulation and translating into a real time. That is the virtual brand. In physical brands, it's nothing but bringing all the physical interaction, so you can have the direct vital parameters analysis. So using all kind of medical device or sophisticated robotic based technology, taking these things and integrating the artificial intelligence mechanism to convert the process into food forensics. So one example I gave is a smart wearable physiological monitoring system. That is the most required, the need of the hour, in the sense that for COVID also, if we come with a kind of a wearable system, which can be used, it's a kind of a wear and tear kind of a concept, so that all the people located in a specific demographic can be monitored and say that whether they have a symptom of COVID or not. So artificial intelligence can play a very important role in it. The other one is the robotic based surgery. Now most of the sophisticated hospitals make use of these facilities, so they will have a trained model and they will make use of this thing. And other way is the doctor can give the instruction and robot can perform the surgery. So these things are possible because of the facilities or the advancement in the artificial intelligence technique. So the AI or the algorithms developed to control the entire operation by means of robot based communication is only through this artificial intelligence mechanism. Look at the history of AI in health. It started with in the year 1970s, where the mycin expert system was developed to identify the various bacteria. With that technology, nothing was there that time. This was the first one in terms of the medical informatics or the health informatics. Then it evolved the tumor model, where people started looking into the development of neural networks and other basic modeling. where the doctor has to identify whether the subject is having any symptom of any non-communicable disease kind of things and all. But during those days, because of the lack in the computational requirement and other things and all, the number of variables were quite high. It was considered as a quite complex procedure. Then people looking into the automation of all the patient records in 80s in the Western world, looking into the entry of all the parameters and recalling those parameters, that really saved that time. So they started looking into the technology for handling the patient data. Then neural networks, even though it evolved in 1950s and all, one of the important component of the AI, it got attention in 1990s where different networks are being used, but they also face a lot of challenges in terms of the clinical realization. That means whatever the input given by the clinicians, it was not able to produce the desired results. But people not give up the things. It got special attention in the sense that any kind of a complex problem or an unsupervised nature of the patterns can be very well recognized by the neural networks. So it got main attention in 1990s. So taking to the current era, now the healthcare data, everything is digital. You name anything, it's a lab-based one or an imaging one or any vital one, and thanks to the facility of the smartphone, now you can collect all your vital using your smartphone technology, where it has an accelerometer. Suppose if you're doing a walking, running, jogging, all those things can be monitored. And if you have a kind of a wearable belt, a wireless wearable belt, it can be very well integrated with your smartphone, and all the parameters can be monitored. And using the mechanism of AI, definitely you can come with a kind of a detection and highlight that whether you are hale and healthy or not. So thanks to the advancement of the digital health technology. Coming to the further advancements in the machine learning, the first and foremost thing in terms of the AI is the high dimensionality feature. So what people have looked into that, if you have a more robust inputs, then there may be a feasibility of getting a very reliable results compared to the very less information at the input. So suppose if you extract important information from your brain signal or a heart signal, if you try to take a high dimensionality data, and if you have no clue about the nature of the target, then you can go for an unsupervised or a supervised training model. Then you can find the clustering mechanism and you can take the call upon. And now the era people are talking about deep learning technique. Yes, definitely it is going to give a kind of a remarkable solution, because there is no training involved in this, no feature extraction and all. It will take care of everything. The only complexity is the computational requirement and huge data requirement. Of course, the role of the healthcare industry in AI is predominant, especially in our region. Karnataka has a special, we have to mention that, because the healthcare sector is the Bangalore or the Karnataka is the healthcare hub, and you have you can take any small scale industries or startups, they always go for the deployment of AI technology using smart devices and all. So taking the IBM Watson or any kind of these things, or Google has come with a very valid Google DeepMind healthcare, where it gives a real-time assessment of your vital parameters. So industries plays a very important role in AI and providing a solution to the clinical care. It's because of the technology and because of the smart technology in terms of wearable monitoring, in terms of applying the robust algorithm, AI-based algorithm. Let's come to the challenges and opportunity for the fraternity or the engineering fraternity. Now look into this scenario. This is an emergency department. So you go to any hospital, the emergency department will have a very crucial role and challenges. At that time, minimum 5 to patients in a critical condition will be admitted. So this scenario is it's one and the same everywhere, no matter whether it's a developed country or a developing country. The resources will be very limited. In rural regions, it's completely pathetic. In semi-urban, urban, to some extent, it's fine. But take into COVID scenario, you all always hear that no beds are available. So when you look into the emergency department, the critical care department, we don't have any kind of facilities. And it's very important that the continuous monitoring of the patient has to be done. The clinicians or the staff nurse availability will be very limited. So what is the solution? The solution is through AI. So if you deploy the AI algorithm, keep all the vital parameters to monitor those things, it will send the alarm. Thanks to the technology advancement, the doctor can get those information using the cloud technology, and he can monitor a centralized system, a centralized staff nurse system, or doctor sitting at his cabin, he can very well monitor the status of the clinician. So this is feasible only through AI and machine learning. Okay. The second factor is the data in the emergency department. So one thing is triaging has to be performed. That is based on the need. Suppose 50 patients are admitted, so you can give the priority based on the vital signs. So if the BP is normal, so say if the BP is normal 120/80, okay, we can say that you can give less priority to the subject. Maybe he may have some other problem, but his BP is normal. So triaging is very important. Then the annotation of the clinician, interpretation of the imaging, for example, the radiological aspect, and X-ray, ultrasound, MRI, all those things, and all kind of documentation about the history of the patient when is being admitted to the emergency care on day 1 and day 3, what is the track record. So all these things is possible by means of AI algorithm. So that means an automated annotation can be done. Yeah, that is called the biomarker. So when a signal is displayed in the clinician's mobile or a laptop or a palm top or a desktop, if you develop a AI algorithm, it will show automatic biomarker and talking about the vital parameters, whether it can label it, it's a normal, nothing to worry about it. Yes, it's threatening, so you have to give priority. So these kind of things can be looked into it in terms of the emergency department, where AI can play a very important role. Okay. Next one is triggering the clinical pathways. Now, looking into the nature of the pathway, for example, say when the subject is admitted or a patient is admitted to the emergency care, and the nature of the steps to be taken, sometimes we have to give them the first priority based on his clinical condition. So if we have a electronic documentation mechanism and using a kind of a mobile app based thing, so that you can give the bed allocation, the priority. Suppose I have limited specialists in cardiology, but I have 5 patients admitted in the hospital at same instant of time. So I can prioritize based on this by deploying a kind of a mobile app, which will take all the vital parameters and give priority according to that. The next one is that the nature of the scenario of the patient. Okay, whether he has a suspected symptom. In terms of the COVID scenario, I have interacted with a lot of clinicians. What they are telling is that suppose the patient is coming for some other surgical procedure, When they screen it, nothing will come. When they go for the radiological aspects or imaging, say X-ray, then it will give a symptom. So it will be quite threatening for the doctors also, because handling COVID patients is very, very critical. So in that scenario, if AA-based mechanism help them to recognize those patterns, which will be more precise and robust, then it will be easy for the clinician to take a decision whether necessary prevention can be taken in terms of screening the COVID patients, then perform the necessary surgical procedure. This is very important in terms of the clinical care. Okay, now sometimes what happens is the patient, because of the panic, he wants to admit to the hospital. So he will say, this is very critical, I have to be admitted in the emergency care. Sometimes the subject may be psychologically affected, not physiologically. So these kind of symptoms can be deployed by using the AA-based data mining techniques, which take care of all the mechanisms. That means you can do the analysis of the facial pattern of the subjects, the behavior, although sometimes the clinical community, when you go to the doctor, they always observe you, your facial pattern, your activities, along with the vital. They don't take the vital immediately. First, they will interact with you, whether you are stable or not, your behavior analysis, audio, sometimes they record, sometimes they take the video, all those things analysis using the AA-based mechanism will give a clear-cut picture about whether the patient or the subject is affected psychologically, whether he has a symptom of, say, chest pain. So it may be due to gastric problem, he may have the pain. It is not because of the irregular heartbeat. So this is feasible using the deployment of machine learning techniques. Fine. The next factor is the risk stratification. Okay, now depending understanding the scenario, whether the patient is in very critical stage, highly critical, whether we can admit to the patient to the ICU. Now the current scenario in terms of the COVID scenario is whether the patient should be given ventilator or not required, because the availability of ventilator is very, very limited. Okay, so in this case, the AA can very well analyze these aspects and take a call, and based on the experienced doctor availability, that won't be a problem. But if a secondary level doctor or the staff nurse is available at that moment, any kind of mechanism has to be deployed. The AA can be used to take it. Now, this is the overall scenario of the clinical conditions. The subject may have the problems because of alcohol. He may have a respiratory problem, cancer, and any kind of diabetic, all those things. He can have abdominal pain, all those things and all. So looking into these things, all these things, the records take a kind of a data mining based decision support system we can derive it. So you list all these things and put a checklist whether the subject is having this thing, whichever they have thing you put that. Then the next level is collect the vital parameters, enter their values. So if you do it for at least for a week time, you will know the pattern. So based on the pattern, you can take the necessary clinical decision whether he has any kind of symptom, for example, say heart related symptom. If he has both heart related and he is a diabetic patient, his sugar level is very less, all those things is possible by deploying the AA-based. Next factor is the documentation. See, in terms of the electronic records, and the documentation plays a very important role. So suppose if you come with a kind of converged aspects or the information about the patient or the subject who is admitted to a hospital, with his history details and all, because it's very difficult for a doctor to go through all his history within a stipulated time. If all the parameters are is visible or it is displayed in front of his monitor, then he can take a call accordingly. So in terms of the documentation and all, natural language processing and data mining plays a very important role to provide solutions. Then the progressing nature of the disease can be easily modeled, and you can predict and you can highlight the future of the disease. What is the nature? So after 10 years, the occurrence of, for example, breast cancer, take breast cancer, what is the prevalence of breast cancer in India, especially in south part of India, all those things. The technology, using this technology, we can highlight it and we can take a necessary step. Okay, after 5 years, the trend may go high. If we take some kind of precautionary step, do the screening, mass screening mechanism. Even mass screening mechanism, you can bring the AI-based technology and do the necessary analysis and give a kind of a research whether they have a symptom or no symptom. Very simple. That is also the can be derived based on the artificial intelligence. As a whole, the drivers of artificial in AI in healthcare is, number one is, you can see a trend in healthcare expenses, whether it's a Western country or in our developing or developing country, the healthcare cost is keep on increasing. And the old age people, geriatric population is pretty high. There will be imbalance between the health force and the patients. We don't have a sufficient healthcare worker. We are seeing the scenario in our place itself that the number of healthcare workers is very limited. That's why we have been advised to stay at home in the case if we have a symptom of COVID, and they are taking some kind of precautionary measures in taking the thermal screening and other things and all to know our symptom whether it is improving or not. And of course, the shortage of nursing and technical staff, and that has to be looked at. So with this trend, definitely the technology, the AI-based technology is going to help them, because it's based on the clinician input, because we are not generating anything on its own. By getting the input from every specialist, we are developing the solutions. So for the community, what are the potential challenges? Yes, developmental cost, initial development, if it is a device smart healthcare deployment, that is nothing but wearable technology, means development cost will be there. But once you deploy it and when you increase the number of devices, and then the cost can be brought down. Then integration issue. My next part is the ethical issue. So it involves legal, social, economic aspect is there. So those factors we need to look at this. And most of the clinical practitioners, they don't want to adopt the AI technology, but now trends have been changed. People want to look into it. People want to work with the engineers, or the clinical engineers want to, clinical community want to work with biomedical engineers or the clinical engineers. And they have a fear factor of, yes, whether this AI is going to replace humans. No, definitely no, it is going to help the clinical community. And next factor is the data privacy and security. So patient record is a very, very important, and the technology can link, for example, say one of the important technology that is required for the current scenario is the integration of the hospital records. For example, say I'm going to a hospital which is located nearby. Okay, the hospital is referring me to go to some other hospital which is located in the urban place. When I go to the second hospital, I'll be asked to take all kind of, for example, testing. It may be a sugar testing, blood test, and imaging, all those things. I have to do it again. If we have the technology and with the help of the government approval, if this data is being shared from the rural place or a semi-urban place to a sophisticated hospital, the cost factor for an individual will be reduced. He can refer it. And the other part is due to the technology advancement, people always assess the data, assess the patient records, and give kind of a solution or an annotation using the technology. So this and all is possible because of the technology. Next factor is the data exchange. So we need to have a continuous training of the data in order to get a robust solution, and lot of regulation. So we need to look into the government regulation, other countries regulation, the demographical regulations. Those aspects need to be taken into account while providing the solutions to the healthcare. Fine. Now let me come to what is the unique feature of the machine learning in healthcare. What are the research problems for the faculty? The first and foremost thing in terms of the clinical scenario is it's life or death decision. That means whether the patient will survive or not. So for that, what is the first and foremost thing? We need to have a very robust algorithm. When I say a robust algorithm, we need to deploy more data. Large data only will lead to robust algorithm. General mindset is that, especially when you want to apply the artificial intelligence or machine learning, we always depend on the data. If the data is small, of course it will give a very good result, say 100% classification accuracy. We may be under the impression it works well. No. When I say a robust algorithm merely depend upon large data set. For any kind of analysis, at least you should have 5,000 plus patient data, and long duration or continuous recording of data will be very much encourageable for developing the algorithm. And the deployment of the algorithm and the validation of the algorithm plays a very important role. So the first unique problem you have is the robust algorithm. Then most of the real-time scenario is complex in nature. Take example the COVID. COVID is totally a complex in nature. There were studies reporting in the newspapers or other dailies recently that the virus pattern is totally different for different demographical area in and around India. So it's very difficult to predict it. So if your subject whether he has a symptom of COVID or not, we need to rely on the unsupervised learning. That means you don't have the clue that whether it is COVID or not. So take all those patterns and bring your clustering concept and go for the clustering mechanism. So knowledge-based decision support system using the data mining techniques and using unsupervised learning procedure like self-organizing map network kind of thing is going to give you a solution. Then the next one, the nature of the problems is very, very casual here in case of the clinical decision support system, because most of the cases we rely on the supervised procedure. Supervised procedure, again I'm repeating, is nothing but the clinicians will annotate the data or label the data. Based on that we will train the algorithm. So this mechanism need to be very, very robust, and it has to be checked with at least 3 to 5 clinical practitioners for a specific problem, so that you will get more input. The reliability, so we know that it's a general phenomena that no two doctors will give a same opinion. Okay, so if somebody suggests you have to go for a surgery, then immediately your mind will say, okay, I will go for a second opinion. So in terms of the clinical solution, it's better to go for at least 3 to 5 clinicians' opinion for initial annotation of the data, and use that one for your validation. And natural language processing is another area where most of the phenomena you will not get the clinician's interpretation and all, they will not be available. So in that case, you have to use a semi-supervised learning algorithm and develop your pseudocodes accordingly. That is one case. Then rare disease like COVID, I've already told you the same phenomenon. There are scenarios where you will not have the complete data information, which is more essential, more crucial to take a decision. Apply a data mining technique. Data mining is a part of the artificial intelligence, which will perform the clustering and rule-based decision. The clustering phenomena will overrule the missing data and will give a kind of a feasible information. So that can be taken into account and you can make use of it. So you have to go for the supervised modeling for known information. If you have the problem with the interpretation of the data, go for a semi-supervised or unsupervised learning. If the data information is missing, go for data mining based approaches or a knowledge based data discovery approaches, which will help you to give a kind of a feasible solution. Let me go towards the research in machine learning. I want to give a few tips. Now it's for the individual. So we, the faculty, so I believe most of them are faculty. Some of them will be interested to do the PhD. So that's why I thought I should include some information related to it. The first and foremost thing is you have to identify yourself where you stand. Identify your strength. What are your limitations? What are your weaknesses? Then you should have the mindset for collaborating with others. Don't think that, okay, I know everything. You should not be hesitant. You should ask people. You have to come out of it. Being open to ask questions and replying in similar and clear terms. It's very, very important. Once you have a collaborator, try to appreciate the contribution of your fellow colleagues. And we need to respect professional boundaries. That means we have to follow ethics. Ethics is nothing but we should not steal others' information. So wherever you have taken other information, cite them, acknowledge them properly. And of course, you should have a very good interpersonal skills. So these are the skill set that is essential for a faculty to focus on the research aspects, and that will definitely will take you to great heights. In terms of the biomedical engineering, what are the global opportunities that can be looked into? Since it's an emerging field and healthcare, it's related to the healthcare, I would say this is an evergreen area. You take any student project, UG student project, 60 to 70% they will take healthcare application because you can use the data, you can apply the data AI or machine learning algorithms, you can introduce the mobile-based technology, you can bring the IoT mechanism, you can bring the cloud-based technology. You name anything, yes, you can do with the help of the clinical care or healthcare data. So this is an emerging field, interdisciplinary field. So a lot of new areas are generating. Tissue engineering, genomics, bioinformatics, all those things are one of the emerging areas. And you need to extend the collaboration with professionals like the professional organizations like IEEE and all. They plays a very important role. They have a good networking nationally and internationally. That will help you a lot in terms of reaching people, understand the research mechanism and what are the work they have contributed. And this field, it talks about the healthcare, nothing but you and your health. So it talks about the well-being of the people. So you can develop the multidisciplinary perspective in problem-solving skills with this field, and that will help you. In fact, if you collaborate with the clinicians and international researchers, you can understand the the level of richness, and you can translate the problem into a feasible solution by deployment of AI-based technology. Having said all these things, I thought, since a lot of faculty members are there, you may be interested to work in this biomedical domain. So let me give a kind of a glimpses on what are the biomedical signal database freely available. So there is no need to go for ethical clearance, no legal involvement is nothing is there. Only thing is you have to give the source of information, or you have to cite the source. That's very important. So the major reference open source database is the PhysioBank. It's a well characterized digital recordings of physiological signals, and you won't believe it, you will find 200 plus databases are available in the PhysioBank. What are the information it comprises of? It comprises of multi-parameter, cardiopulmonary, neural and other biomedical signals. You will find healthy data and with other conditions like sudden cardiac death, heart failure, epilepsy, gait disorders, sleep apnea, and aging. So specifically, you will find ECG related database, respiratory BP database, and EEG database. So other database listed in PhysioBank is synthetic data. Synthetic data is a very important one where you need to give a special attention in the sense that if you want to use the deep learning mechanism, then you try with a synthetic data, you can use the necessary algorithm to simulate it, then you use the real-time data. So these are another database, neuromyoelectric database. One data is the CHB MIT database, is a EEG recording. Also, you will find deep brain stimulation on Parkinson tremor, other things also available. So you just Google synthetic data, you will find all these information, and along with the statistical analysis and surrogate data analysis is also available in this database. One important data is the MIMIC database, where you will find 40,000 patient data. This is huge. Most of the researchers make use of this data. It is also a part of the PhysioNet database. Then multiple myeloma. This is another database available. You just Google it, multiple myeloma, you will get this freely accessible database with complete data history and the platform that can be used. All those informations are available. Yes, Parkinson, this is database. This is freely downloadable, 400 plus database. You can see the level of electromyography and other physiological signal related database in this Parkinson disease database. Then American Heart Association database. So it contains, these are the records. You have a lot of PVCs database and other all related arrhythmias database. All these things are available. Then if you want to use for electrogram libraries, you can make use of Ann Arbor database. Then congenital heart failure database. This is also a part of the PhysioNet database. So you can't give a kind of a solution. You don't have any data. All these open source databases are readily available. You can make use of it before approaching or taking the real-time data. Then cough sounds, the phonocardiogram related database is available in this link. BCA competition database, very, very important database, is a EEG based database. You will find a different competition of brain computer interface database. Then comes the EEG database. This is a open source database where you will find 14 subjects. This can be a very good starting point. It is say go, no go, binary classification procedure. UCI is a very large repository. You will find all related database in case of the UCI. If you want to go for epilepsy, this database is available. Epilepsy Center for University Hospital of Freiburg, Germany. And apart from that, you can also make use of this biosignal open project where you will find a lot of pseudocodes and other platform available, which you can use as a kind of a starting point. A lot of open source libraries are available in this platform where you can make use of it, and it uses a lot of physiological system starting with EEG, EVOG, electrocardiography, all those things. And it makes use of MATLAB and Octave, these things, and all the library functions are available. This is the best platform for you to start your work. Coming to the medical imaging database, these are some of the open database available. See, it says as finger image, computer vision, test images, all these things are available. Mammography database, this is a specific database which can be, I think, lot of work, a lot of results have been reported using this database. So you will have 86,000 subjects data available. Then if you want to go for microbiology based or pathology based database, all those things are available. Microimaging, pathology related things are available. Using the electron microscope, imaging has been done and these data are available in the open source. Then lung cancer and the diabetic retinopathy. So these things are available, freely available. You can start your work using this. So finally, I would like to tell, if you want to focus more on your research for your PhD, those who have completed PhD, it's well and good. Those who are doing research, based on these important points, you have to be very, very clear in terms of your requirement. In case if you want to work on AI based or machine learning in healthcare, the advantage is that you have a lot of open source data. The second thing is work with this open source data, then approach clinicians who is who is in your contact, or you can go to a local hospital or a urban hospital. Only thing is you have to do the ethical clearance. That is quite challenging, but once you are cleared, you will have a lot of data to work on it, and you can focus on the nature of the machine learning algorithm, which area you want to work, whether it is a natural language processing or neural networks, data mining. You label, you decide it, and you can work it, or you can integrate all those things and all. So while doing this process, please ensure that when you write any technical papers and all, please write everything is on your own, because plagiarism is very dangerous. Most of the cases, most of the journals or conference, they always check the similarity content. So make use of Turnitin like software. Online free software is also available. The content writing is quite challenging. Try to write in a simple language, and try to take the content which is already available. If you are taking the 1 or 2 sentences, please cite. Is nothing wrong in doing so. So with this, I would like to stop this session, and probably I can go for a question session.
Thank you, sir. It's a really valuable information, sir, and information session also. A lot of appreciation is coming, sir. And I request the participants to post your queries in the chat box, or you can unmute and one by one and ask. Yeah, definitely we'll share the presentation in Google Drive.
Good morning, sir.
Yeah, ma'am.
Sir, this is one of the participants.
Yeah.
My area of research is somewhat related to this presentation. It is data analytics in healthcare systems.
Okay.
So, sir, I just started my research. I just joined the PhD program. So now my question is, I am not getting any path which way to go in the healthcare as it is very vast. So I am in a bit of, I'm reading a lot of research papers, a lot of articles regarding this field. I just wanted to ask you, can you please guide me for taking up any area where I can do my research in the healthcare? Like we can go for neural networks, how neural net can be used in healthcare data analytics, how association rule-based mining can be used. There are a lot of techniques, right? So I am in a lot of bit of a dilemma to what to choose. Can you
Yes.
please
Yes.
help
Yes.
me in this, sir?
Yeah. First thing, that's why I told the tips like identify your strength and weakness. First thing, you may not be knowing that what is your strength. So first thing, relate the field which you are capable, which is fascinating for you, even though you don't have any kind of a track record. So identify, for example, signal processing. If you are good in signal processing, image processing, that is sufficient for you to work in AI and healthcare. Second thing is the purpose of sharing these open source database is generally researchers will be wondering how to start it. Very simple. You use these open source database. There are a lot of published articles reported in using this database. Try to duplicate same thing with a simulation software which is available in the open source. Very simple. So that will give a kind of a confidence for you to learn something, then you go for it. Okay, this is very important. So you might be not knowing that where to start, how to start. This will be the
Exactly.
first starting point. Second thing is people are asking that how to start with this. For example, no need to go for real-time data. You can start with the open source database. Then you can go for the real-time data. By the time you will get more information about that. So EMG database selection procedure is nothing but it's available of the data. Only few data are available in the open source. So you can use the Parkinson disease or gait data where you will have the trends of EMG in that you can look into.
Sir, and one more thing. Uh, how to go for the technique? How to decide which technique can be best suited for
Very
that
simple.
particular data set?
The basic starting point is that you start with a neural network. Neural network model holds good for any kind of problems. Okay, any kind of complex problem that can be deal with neural network. Now, lot of simulation software is available in the open source. MATLAB is the best way to start with that. Lot of MATLAB GUI is available. You can directly deploy those things for your initial study.
Okay. Thank you, sir, for answering this.
Thank you, sir. Okay, sir.
Hello, can you hear me?
No need for computer
Oh,
engineers. There is no need to go for biomedical these things and all. You are analyzing the data, so you should have a minimum knowledge in terms of the medical data that all the open source information is available. So nothing to worry for the computer science engineering because computer people can do a lot in terms of these things because AI or machine learning is the fundamental aspect of computer science engineering. No doubt in that.
exactly, sir. I am from computer science. That's why I'm asking this question to you.
Yes.
I'm doing my research in it.
Okay.
Thank you, sir, for answering. Thank you.
Hello, good morning, sir.
Yeah, please.
Basically, my name is Rabil Gohra. I am from the UCT View Hazaribagh.
Okay.
So my research field also in related to the EEG signal or ECG signal and using the machine learning technique. I have just one question. I have some doubts regarding that.
Yes.
One thing regarding EEG signal, how to converting in vector means if any type of the EEG signal, how to convert in vector. That's
Yeah.
my
Sir,
just question.
this part I'm going to discuss in my second session. I will
Okay.
be some case studies related to this. Maybe at the end of the session, I can give you a better
O-
picture about it.
Okay. Okay. Thank you, sir.
Hello. Hello, sir. Sir,
Yep.
one of the participants has asked from Deepti Kulkarni, madam, if we are going through the research in biomedical, whether we should go with real-time data or ready available data is okay.
Yeah, I've already answered this thing. So to start with, to gain more confidence, you go for the open source data. PhysioNet is the ideal starting point. Use this database, get the results, whatever people have reported already, so that you will be ensuring about your pseudocodes or algorithm. Then you contact the clinicians in the local hospital. Then
Sir, hello, one more question,
Hello,
sir.
sir. I Alka Mishra.
Yeah, go ahead, Alka, madam. Go ahead.
Okay. Sir, I am doing PhD on signal processing, and I want to generate synthetic signal. And I have started from interpolation and curve fitting for getting the equation of synthetic signal. Sir, any other option from which I can go for the generation of synthetic signal?
yeah, you can
Can you
go
guide me, sir, please?
techniques. Lot of augmentation techniques are available for generating the synthetic data. You can Google augmentation techniques plus synthetic data. You will get lot of techniques.
Okay.
Okay, thank you, sir. Sir, one more query from the participant. What is the EMG database selection procedure?
That's what I told. EMG database procedure is a very limited electromyography data is available. So which is related to gait as well as the Parkinson disease. So if you are interested in EMG, you start with that. And there is a possibility of getting a biopack equipment or RMS EMG equipment, which cost around 3 lakhs to 4 lakhs. So probably you can get that equipment and record the healthy volunteers to start your. That is also possible. You will get a digitized data.
Okay, thank you, sir. One more question. Is there categorical data enough for classification?
Categories, that's what I told. See, we have to do justice for our work. Our claims should be strong enough because this the nature of algorithm we do it. This is not dynamic in nature. For example, most of the algorithm it works today, it may not work tomorrow, and lot of training, all those things has to be taken into account. So the nature of data which you select plays a very important role. So if you want to use artificial based technique, at least your database should be at least 5,000.
Okay, sir. There is one more question from Krishna Kant. For someone from computer science engineering, do we have to do any courses in biomedical to do research in AI in this field?
I think, ma'am, I've already answered. That is not required. You should
Yes,
have
ma'am.
the basic knowledge about the
Yes, sir.
data
Yes.
that you will know once you start working on it, because AI and machine learning is the fundamentals of computer science engineers. So you can very well do, and in fact, you can use the best platform, Python and C++ is the best for these people, the computer science people. And if you want to develop a product or software to be integrated with any kind of a device, computer engineers can play a very important role, and no doubt in that.
Okay, thank you, sir. I request the participant, again, we have one more session from Dr. Sriram, sir. So we'll join at 11:30. So that time again, we'll have a once again discussion. Sir, it's a really informative and valuable presentation, sir. Thank you very much, sir. And lot of appreciation is coming. And we'll meet at 11:30, sir.
So I can disconnect,
Okay,
right?
thank you, sir. Yes, sir, sir. ಸರಿ ಅದೇ ಸರ್ ಹಾಂ ಮಾಡಿ ಸರ್ ಒಂದು ನಿಮಿಷ ಇವರಿಗೆ ರೆಕಾರ್ಡ್ ಮಾಡಿ